Hello, and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of slope-intercept form. This is 7.7a Readiness Practice, the Proficient version. If you are interested in exploring the 7.7a Readiness Practice for the intermediate or advanced versions, or the Readiness Practice resource aligned with any other standard, you could find those by using the link in the video description. So we have our first story problem here, renting a bicycle. There's a flat fee. It's $5 just to rent it, and then it's a per hour fee. All right, so we need to write this in an equation, and let's write this. This is our linear equation that we'll be learning about starting in 7th grade, and we'll be using all the way through the rest of our mathematics. So this is very important. This is what we call slope-intercept form. We know what x and y are, right? So these are our two variables. This is our independent variable, and this is our dependent variable. What is m? Well, m is our slope, or we can think about it as our rate of change. So we have our independent variable x, and something happens to it, and it's our m. It's going to change. And then this is our y-intercept. And so they take those two terms, slope, y-intercept, and they just turn it into the slope-intercept form. And so this answers the question, what happens at the start? So what happens when x is 0 before anything begins? Well, so let's write an equation here. So what is our rate? Well, we've got two numbers here that we can see if any of these are a rate. And you see we've got a clue right here, per hour. So it's going to charge $2 per hour because our independent variable, right, is going to be our x right there. It says x hours down here. Usually they will define it a little bit later on if you look. And then our total cost is going to be y, so that's going to be, so we'll say hours and cost. All right, so it costs how much? How much an hour? What's our rate of change? $2 an hour plus what happens before you even rent anything? We got to pay that $5 fee. Now, the $5 fee doesn't increase at all, but it's always there at the beginning. All right, so write an equation. Let's put this in this pink right here. Now let's make a table. All right, now I'll show you kind of a slower way to make a table. If you want, you can write it just like this. Y equals 2x plus 5. And we can just kind of do it like this. So let's say our x is 0. Okay? 0 hours. 2 times 0 plus 5. Right? Well, 2 times 0 is 0. Add the 5. That's going to equal 5. So it costs you $5 just to walk up. Now, 1 hour. 2 times 1 is 2. Add that 5. That's going to get you 7. Let's see what happens at 2 hours. And that's going to be 5. And that's going to be 9. Now it's just going up by 2. As you notice that the y is just increasing by 2 because that's our rate. And then we can jump. We don't have to necessarily stay in order. Let's see what happens if you keep it out for 5 hours. Well, that's going to be $10 for the bike plus the $5 initial fee, so that's $15. Now, typically what we'll do is we will just list it as an input-output XY table. So let's just take our x's, 0, 1, 2, 5, and list our y's. But I wanted to show you the math behind each of these y's. So that is our answer on the table as well. For number 2, we need to first write an equation and then draw a line on the graph. Okay, so how could we figure out the slope, the rate of change? Well, one way to think about it is this. Our rate of change can be calculated if we look at the change in y over the change in x. So we're just going to pick two different values here. We're going to make this a y2, y1, x2, you want to make sure they're lined up, and x1. So what's the change here? Well, I've got a 13 minus 9. That's a change of 4. And a 4 minus 2. That is a change of 2. So what is a change of 4 over 2? That's going to be 2. All right, so my rate of change is it goes up 2 for every x that it increases. So my x increases 2, so that means this is going to increase 4. My x increases 2, that means this is going to increase 4 because it's 2 for every 1. So my m equals 2. I just need to find my b. What happens when x is 0? Well, let's go backwards. It goes down 2, which means that's going to go down 4. What's down 4 from 9? That's going to be 5. So we can say y equals 2x plus 5. Hopefully that looks a little bit familiar because we just figured that out, but we figured it out from the opposite direction. We figured it out from a table of values. So that is our equation. It's the same equation we've already used. Now let's graph it. All right, so let's take these table of values here. I'm going to start with 0, 5. I'm just going to have 2 points here. 0, 5, 2, 9. The rest you notice is off the graph. So let's come up with some points in between. All right, so it's a rate of change of 2. So my 1, I'm going to add another point here. 1 is going to be 7, right, because that's 2 more than 5 or 2 less than 9. So let's add that 7. Bet you I can get a 3 on there. Let's see, 3 is going to be an 11 because that's 2 more than 9 or 2 less than 13. Now I'm done. Kind of off the graph. So let's add this line here. We're just going to start with that 5. It's going to kind of move up. It probably hit that 13. And that's going to be it for us. So that's our line on the graph. You notice it's starting at 5 because that's the initial setup fee. For number 3, we just need to draw a graph. And they don't give us an equation, they give us this verbal description. Y is 5 more. So let's do 5 plus then 1/3 the value of x. Okay, so y equals 5 plus 1/3 the value of x. Let's go ahead and put this in slope-intercept form. That we're just going to switch the 1/3 x and the 5. Okay, so y equals 1/3 x plus 5. Now, you see this plus 5 right here? This lets me know that that is going to be my y-intercept. So I'm going to plot that right there. So I've got a point right there, and that's going to be 0, 5. Now they also give you the slope. Slope, or the m, equals 1/3. So really what that is that's a rise over run. Change in y over change in x. That means it goes up 1, and it goes over 3. 1, 2, 3. It's a very shallow slope. Okay, so that's going to be 3, 6. Goes up 1, and then over 3. 1, 2, 3. And that's going to be, what is that? That is 6, 7. Up 1 over 1, 2, 3. We are now at 9, 8. Up 1 over 1, 2, 3. And that's the last one we can get on this graph. That is 12, 8. No, that's 12, 9. We graph this. Let's get that blue. Let's get a line. Put that right there. Now, if you're not sure about this, let's test a few. Okay, so I put my points on here. And so let's see, if y equals 1/3 x plus 5, does this last one work? So my y is 9, my x is 12, Let's make sure this works, okay? Because we weren't calculating, we were just using the fact that 1/3 is our slope. That means we go up 1 over 3. They're both positive. If 1 was negative, we would have to go either down or to the right. Okay, so 9 equals, what is 1/3? 12. That is 4 plus 5. 9 equals 9. So we did it. If you are interested in exploring the 7.7a readiness practice for the intermediate or advanced version or the readiness practice resource along with any other standard, you can find those by using the link in the video description.